So now we're going to do page 386, and we're going to do number 19. I think you're going to have 18 and 20 as part of your homework. We're going to do 19. So I've taken this graph right here. Oh, the question says, find where the particle is. It's a little, I guess it says the particle starts at x equals 2 when t equals 0. I didn't notice that. We'll have to use that. Okay, and then we're supposed to find the total distance traveled by the particle. All right, but then all they give us is a graph. So I might add this in. They said that x equals 2 when t equals 0. So that means that x of 0 equals 2. What do they give us? Units? Yeah, they give us meters per second and seconds. So even though they just say the particle starts at x equals 2 and they don't give units for that, it means 2 meters. We know because velocity is meters per second. Okay, so if we want to know, the question says find where the particle is. So all we have to do is find the displacement, all right, and then add it to the 2 meters that it was at time 0. So we'll start by finding the displacement. So for displacement, displacement means we're going to do the integral and we're going to consider the negative areas as negative and the positive areas as positive. So the displacement is, like if I think of this triangle and trapezoid and triangle, right? So the displacement is going to be the negative area of the triangle plus the area of the trapezoid minus the area of the triangle. So this is a little bit like weirdly ambiguous because when I say negative the area of the triangle, do I mean the area of the triangle was already negative and now I'm going to put a negative to make it positive, right? So I'm counting the all these areas as being positive, and I'm saying, okay, for displacement, I need to count this as being a negative area, and this as being a positive area, and this as being a negative area, because if I go to the left and then come back to the right, and I want to know where I am, I need to keep track of that there's a difference between going to the left and going to the right. Right? For total distance, there's no difference between going to the left and the right, but for displacement, that's different, so I need to consider them as being different. So it's not too hard to figure out that this area of this triangle is 1, so I'm going to have -1, and then for the trapezoid, I never use trapezoid. I never use the formula for trapezoid. If I want to find the area of a trapezoid, I just break it up into triangles and rectangles. So this is 1 by 2, so it's 2. This is a 1 by 2 triangle, so it's 1. This is a 2 by 2 triangle, so it's 2. Right? I never use area equals 1/2 base 1. Where's it? 1/2 height times base 1 plus base 2. I never use that because it's quicker to break up a trapezoid into rectangles and triangles. I mentioned that because it might be a skill. Like you have to find areas like this all the time on the AP exam, and speed is of the essence. So if you're in a no calculator section, you're getting a trapezoid, even if it is calculator active. It's quicker to get this by doing rectangles and triangles than by doing 1/2 h b1 plus b2. Anyway, unless you spend like 5 minutes talking about it, then it's not quick at all. So that area ends up being 5, and then this is, like I think of this area as being 1/2, and this is 1/2, so it's 1/2 plus 1/2 is 1. You can also think the base is 2, the height is 1, so 2 times 1 times 1/2 is 1. Anyway, that area is 1, the displacement is 3. Okay, so that means the question, where is it? Okay, so the position, we don't know how much time this took, do we? Oh no, this is time in seconds. So the position, we could say, by the way, that s of 7 is the position, right? Because the position at time t equals 7. This is t, this is 7, all right? So I guess they said x of 0, so I won't say s of 7, I'll say x of 7 is equal to the 2 that it was already. Well, I'm going to write this way, x of 0 plus displacement, just because I like to really neurotically write out everything. So my x of 0 is 2, my displacement is 3, so that equals 5 meters. So the position is 5 meters, right? But it only moved 3 meters. So the only reason it's at 5 meters is because it was already at 5 meters, so, 2 meters. So what happened to this object? Like if you think of, this is an x-axis, right? This is a t-axis, so that's misleading. This is an x-axis. So what happened was this object went to the left, and then it went to the right, and then it went to the left again. So it went like left, right, left, okay? But it started at x equals 2, and 0 is over here. And it ended up at x equals 5, all right? So the actual displacement is 3. That's our 3 right there. Okay, now what about total distance? So total distance is going to be different from displacement. So total distance, I just consider all the areas to be positive for total distance. So I'd go triangle plus trapezoid plus triangle. So that's 1 plus 5 plus 1, which is 7, right? Yeah, 7 meters. So that tells me that the total distance that this thing went, when it went from here to here to here, that's a 7-meter journey that it took to end up 3 meters from where it started at position x equals 5, when it started at x equals 2. All right, so that's using a graph to answer distance and displacement problems. So the next thing that we're going to do is we're going to look at this other worksheet that I made up many, many years ago called Advanced Particle Motion. And this time, it's not asking where the particle is or what the total distance traveled is. It's asking you to write an equation for S of t, V of t, and A of t. So that's going to require some special new considerations too. So that's what we're going to do next. This is page 386.